Okay, so maybe on a pad of paper or something, or maybe just talk out loud. I really do, this is a great exercise. Try to talk out how you would figure out a bound on the age of people in this class. So math 299 or your section. Okay, so after you've done that, now I want you to think about, now try to figure out what's a bound on age of people enrolled at MSU. This is kind of a hard question, it seems, right? But let me give you a hint. We just want a bound. So sure, maybe even if we do try to get everybody together and we ask or something, but do we need a precise bound? Do we need like to know who is the oldest person and maybe do one more year than that or something? No, we just need a bound. All right, so how about 200 years old? That's certainly a bound, right? I don't think there's anyone living on this planet right now who is over 200 years old. So that would be a bound for both of these cases. We could say 200 for both. Okay, so I just want you to keep that in mind. We're not looking for the best bound or the closest bound or something. We just need a bound. Okay? All right. So this is a little bit different than what we'll see in general because we're only talking about positive numbers, okay? Because no one can be negative some year old, okay? So let's talk about our general mathematical definition. So say, let A be a set. Oh, no, sorry. A set X is a subset of R is bounded if there exists some M in the positive reals. Okay, so not including 0, just the positive ones. Such that for all elements in our set that's bounded, the following is true. So absolute value of X is less than or equal to M. Okay? So some of the elements could be, their absolute value could be our bound. Okay? All right, some notes on this. X varies over all of X. But M is fixed once you pick it. Okay, so I say pick it in quotes like that because a lot of times you're going to use Archimedean property, to figure out who M is, so maybe you don't actually know who M is. But once you choose an M, that's it. We're not changing the M again, okay, unless you're talking about a different set. Okay, but X is going to change. X is going to be any of the elements in our set X. You can't pick infinity. So once you choose M is less than infinity. Okay, so because you know how to negate statements, you should be able to know how to state what unbounded means. Okay, and so we're not going to really go into unbounded sets this week. We're going to talk about that next week. But you should know from this statement, you should be able to know how to negate this and get the definition of unbounded. So I'll write it out. But you should pause and try it on your own. It's a good practice. A set X is a subset of R. Is unbounded if for all M in the positive reals, there exists some element in our set such that, okay, so absolute value of X is strictly bigger than M. Okay, let's do a short example. So what's a bound of the interval from -10 to 0? Well, we could pick 10, we could pick 20, gajillion, Jeff Bezos's net worth, whatever you want to pick. It just has to be bigger than or equal to 10. Okay? So maybe I'll just write 25. I don't know. Okay, So now let's do a proof to show something is bounded. Show the set X where the elements are little x such that X divides 21 is bounded. Okay. All right, so something that's kind of nice about bounded proofs is oftentimes you can just figure out what a bound is and then just show that that has to be a bound, okay? So let's think to ourselves, what has to be true for X to divide 21? So why don't we consider, so we're not assuming, notice, remember we can't assume stuff, but we can always ask the reader to consider something. So consider M equals 22. Okay. So maybe before I do that, maybe I do some scratch work or something, just whatever works for you. So X dividing 21 implies that there exists a K in the integers such that X times K equals 21. Okay. So, here we go. This is a good argument. Then absolute value of 21 equals absolute value of X times K equals absolute value of X times absolute value of K. All right. Well, 22 is bigger than 21, which equals absolute value of X is X value of K. I got a little ahead of myself. That's okay to do that, but you don't want all your work to be in your scratch. Okay, so here's what I wanted to be in my scratch. The bigger X is, the smaller K is. Or, absolute value of them. Okay. And an absolute value of K is bigger than or equal to 1. Okay, so it can't be 0 or else this just doesn't work. Okay, so not this problem, sorry, it's just it wouldn't be the right integer to choose. Okay, so here we go. This is what I would want. Yeah. Okay. By scratch, if X divides 21, there exists a K in the integers such that all of this is true. Here, there's a better way to say it. This is going to be less than or equal to absolute value of K, absolute value of X, since K is in the integers minus 0. So, okay. Then 22 is always bigger strictly than absolute value of X. Okay, so since it's strictly bigger, we could always say bigger than or equal to. That's also fine. Since we showed this for a generic X in our set, then X is a bounded set. Okay. Boom, roasted. I hope that wasn't too chaotic. Okay. Another one. All right. Show that the set A, which equals cosine n to the 5th power over 2 to the nth power, such that n is in the naturals, is bounded. So this week we won't ask you anything about unbounded. I just kind of wanted to show it to you because you could have figured it out on your own. So I thought it would be nice. Okay. Proof. Okay, so maybe we would start with the scratch work here. I don't know. I don't know how you're feeling. But hopefully good. That's my hope for everyone. Okay, scratch. So what's something that we know about cosine? We always know that cosine of a real number. If you don't get that joke, that's okay. Maybe someday. All right. So scratch, cosine of a real number is always between -1 and 1. Okay. So what does that mean? So then we get that -1 less than or equal to cosine of n to the fifth, because n to the fifth for n in the naturals is going to be in the reals. Okay. Cool. And so you might be wondering, well, why am I doing all this scratch for myself? You're also doing it for the grader, okay? So I wouldn't actually put this on your scratch paper. I would put this on the problem that you're doing so you can reference it and show that you did a lot of work. So then that has to be true. Okay, so here's where things might get kind of weird for people maybe. Also, for n in natural numbers, 1 is less than or equal to 2 to the n. This is by induction. So people always ask me, okay, well, do you have to show this induction? And no, you do not. For things like this, no. Unless that's what we're asking you to prove, of course. But for things that you learn in calculus, oftentimes, unless we're literally asking you to prove it, you don't have to show it too explicitly. Okay. All right, so I know I'm really going in on the scratch work. I'm like basically doing all my work here, but that's okay. This is how I'm figuring out what my bound is, or what I'm going to choose, what I could choose as a bound. Okay? All right, so by induction, that is less than or equal to that. Well, we can actually separate these, so we get cosine of n to the fifth times 1 over 2 to the n, because that's always going to be positive. Okay? Well, this is less than or equal to 1 times 1, which equals 1. Cool. All right, so let's set our m to be that. Whew, a lot of scratch work. Consider, and you don't have to call your bound m. You can call it what you would like, as long as it's not conflicting with other notation. So let x be an a generic, or just, you just pick a random one. You don't even have to say generic. You just say let x be an a, because you're not fixing it as anything. You're just saying it's an a. Okay. Then there exists an n in the natural numbers such that x equals cosine of n to the fifth over 2 to the n. All right, cool. Absolute value of x equals absolute value of cosine of n to the fifth over 2 to the n, which is less than or equal to 1. So I'm going to say by scratch. And you really want to say that. You want to say by scratch or arrow scratch. Okay, and that equals m. Thus, because I'm feeling fancy, I don't know. Since x is an a is generic, m equals 1 is a bound for a. Hence, man, I'm really feeling fancy now. Wow, and correct punctuation, maybe? Yeah. So that's another thing that I forgot to mention. When you're doing these proofs, you'll want to mention what the definition of bounded or unbounded is somewhere on the page. Okay. Goodbye.